Alright, welcome back to Plan Z. Today we're going to figure out what tools we'll need in the CNC to actually make this part. Now, before I get going, there was a mistake in my last video that a couple of people caught, or I'm assuming a couple of people caught, but I caught right after I made the video. This whole thing, from the top to the bottom, oops, that's the wrong measurement, from here to here, should be 0.725, 725 thou. Okay, right here. That's 725, not what I have, which is 0.75. So what you're going to need to do is re-extrude it. Okay, so I'll just delete this real quick. I went ahead and made a sketch on the bottom, and then just extruded it. Well, I don't even have to do the math. 0.75 is what I have, minus 0.725 is what I need. I want this to be negative. So I should cut just a little bit. Uh-oh, I've done something wrong. I'll do plus. Maybe not. Well, I know it should be. I just not have a point. Let's do the whole thing negative. 0.75 minus 0.725. There. Nope, that's not right at all. What should the measurement be? 0.725. How big is my whole thing? Yeah, 0.75. That's interesting. Alright. Well, here. 0.75 minus 0.725, 0.025. So, negative 0.025. That's what I should be cutting, but that seems too small. Oh, that's right. Okay. 0.725. Alright. So it's just 25 thou too long. So, alright, there you go. Let's double check and make sure this measurement's right, because this should be 0.3, which it is. 0.3 down from this contour here. Should be 0.3 down, which it is. So that's good news. Alright, now we got that out of the way. So now we're going to make our tool library for our CAM software to make. So in order for us to write the program, I'm talking to my students, kiddo. You okay? You want to see what I'm doing? All right. I'm making a CNC part. You want to help me? Yeah, come here. All right. So, me and the daughter are both going to create a tool library for this part. So before we can actually have the machine recognize the tool pathing, we have to tell it what tools we want to use. So, at the top left, we're going to click Design, which is how we made it. We're going to come down to Manufacture. Okay? So we're going to manufacture it. Just to get in position the way you have it on your print, it looks like this. Okay? So we're in manufacture. We're going to come all the way over here to manage. I want to manage my tool library. I'm going to start a brand new one. I'm going to create a local one. I'm going to right click. I'm going to say new tool library. I'm going to call it NIMS, CNC. Okay? And I'm going to come up here. And I have already listed out all of the tools that we will need for our operations. Okay, we're gonna need a 3/4 4 flute. Yeah, you can have the marker, kiddo. A 3/4 4 flute carbide, a 1/4 inch carbide for the slot. Oh, this is gonna be for edging and the contour. This is gonna be for the slot. This one is for feature A. It's just a drill bit. This is for feature B. It's just a drill bit. Okay. This is gonna be a for feature F and feature G. Now, remember when I told you that if I have a 1/4 inch hole, I don't want to use a 1/4 inch drill bit because it's going to wobble. The CNC is so precise, it doesn't matter. I can get that measurement with the high precision of this tool and the high precision of the machine. So I don't have to worry about reaming like we will with our benchwork layout part. So I'm just going to go ahead and use a high precision tool with a high precision machine like the CNC Haas that we have in the school. and it will give me if I use a 1/4 inch bit, it'll give me a 1/4 inch hole with 5 thou leeway. Okay, so don't have to worry about that. And the last thing I'm going to add, the reason I had this at the bottom, in terms of operations, this should go all the way at the top. But I'm going to do it last because it's kind of a pain to make. So I'm going to go ahead and, once we get a handle on how to make these, then we'll make this Sandvik face mill. You are helping, kiddo. But in terms of operation, this face mill is what we're going to use to get the part down to 0.725. Okay? So, but first, we're going to go ahead and create our tool library. Okay, so the first up is 3/4. So, I'm going to go in here. I'm in my tool library, just in case. Let's do it again. Manufacturer. I was in design. Now I'm in manufacturer. Whoops, that's simulation. Don't want that. Shush now. Manufacturer. Tool library. NIMS CNC, I'm going to add a tool. So this top right, we're going to go ahead and make this from scratch. The first tool we're going to add is a flat end mill. Okay, we're going to make this guy, this 3/4 SGS S carbide. So it's going to be 4 flute because I'm sorry, 2 flute because we're working with aluminum. Okay, it's going to be a clockwise spindle rotation. Here, move it. Okay, everything is pretty good except I want to make sure this 0.75. I don't have the tool lengths in front of me, so we're just going to go ahead and go with all of these as our things. Now, we are going to use a carbide tipped, and no coolant through, it's just going to be normal coolant, and that's it. Hit OK. And that is one tool that we're going to use. And if we need to go back, we can edit this tool and say, hey, it's really going to be 2 inches long. Okay, but I don't know the tool off the top of my head, so we're just going to go ahead and go with the default. Okay, next up, this one. Okay, this is going to be for the slot. So if you look at the slot feature here is 0.182 radius, so 0.1875. Okay, so 187.5 thou, which gives me, that's the radius. So the diameter that we'll need to use is 0.375, which is 3/8. So I'm going to go ahead and use a 1/4 inch slot and do 2 passes. So I'm going to drop that 1/4 inch slot, and then it's going to cut on the left side, go over, cut on the right side, and overlap itself and create that slot for us. So we're just going to go ahead and use a 1/4 inch carbide tipped bit. So we're going to come in here, add tool, another flat end mill, okay, 2 flute, not hardened steel, but carbide. We're going to have a 1/4 inch diameter. Boom. Again, everything's going to just snap to, and that's going to be fine with us for now. Okay. Next up, 0.32 drill bit. So 0.312. Uh-oh. There you go, kiddo. So, we're going to use a drill bit. Where is it? Drill. Okay. It's going to be a 2 flute. It's going to be hardened carbide. And 118 is fine. The only other version that we would have used is a 135, but we're going to be using 118 jobber bits because they're a little bit more prevalent for us. And we're going to go ahead and call the diameter 0.312. Boom. And that's it. Next. So here, let's just go ahead and start checking these off. Next up is 0.218. So come down here, select drill bit, 2 flute, carbide, 118, and this was 0.218, 0.281, sorry, 0.281, 0.281, that's right, hi kiddo. Boom.
Where's the marker?
The marker's in your hand.
In there?
Uh-huh. 0.213 for F, 0.213, 0.2, where is it? 2 flute, carbide, 2.213, right. Boom. Okay. Nope, not that one. This one. 0.213. We did that. 0.25. There's our 213. So 0.25 drill bit. 0.215. 2 flute carbide. Okay. And last but not least, all right, last but not least, our 3-inch face mill. So we're going to be using, not this one, this one. Okay? This is the face mill that we will be using. So we're going to make it based on this. Again, I don't have the exact measurements on here, so I'm going to have to go and look it up. But for now, we're just going to have it basic tool path so we can get our tool in our library.
How you do that?
Yeah, we're going to make that. You ready?
Do it with you.
Awesome, kiddo. All right, so we're going to go back up here. Okay, we're going to come in. We're going to use face
I'm
mill.
not helping you with that.
You're helping. Can you click this button?
Which one?
Just touch the screen. Yep, that middle one says diameter. Oh, do it again. One more time. One more time. Good job, kiddo. Hit 3.
3?
Yeah, can you pick 3 on the keyboard?
3 on the table?
Yeah, pick 3.
This one?
That's 4.
This one.
That's 1. That's 2. That's 22. That's huge. Hit 3. Yeah, you're 3. Oh, that's 33. No, that's 333. That's huge. All right, number of flutes. Just going off the picture. 1, 2, 3, 4, 5. They're all inserts. So 5 flute. Again, we're going to use clockwise spindle rotation. And it's going to be carbide. Okay. No through coolant. Everything else is going to be fine for now. I mean, we could mess with the taper. I think it's 45. Nope, that's not the right taper I want to use. Corner radius, maybe. Nope, definitely not that. No, 0. That's fine. All right, and that's it. And then we're done. So then what we'll do next time is we'll have to come in here, do a setup. Okay. Since we set this thing up right, I'll actually show you how to face this thing. This is what we're going to do next time. This is not part of the assignment. The assignment right now is just to make... Shush now. Nope, not that. You're going to make this, take a screenshot of this whole thing, do canvas, and that's it. But just to give you an idea of what's going to happen next time, you guys are going to use the face.
I don't need this anymore.
You don't need that anymore.
I didn't hear.
We're going to select our tool.
Just like this, like this, like
3-inch face mill. Okay. We're going to select contour. This one.
I did this in here.
And hit OK. And then when we look at the simulation, simulation.
I don't want it.
Turn our stock on. You'll see it actually start to level out the piece. And then the next thing we'll do is a contour.
That's in there.
We're going to select our tool, which is not that. Hold on, kiddo. It's going to be a 3/4. Again, I'll go into major detail about this next time, just to give you guys an idea of what you're going to be doing. Again, I haven't set my speeds and feeds, but this is generally what it's going to look like. Simulate. So this one will look like this. Again, there's some more things we have to do, but together it'll look like this. And then we have a tool change.
I don't read this anymore.
No? Okay. Again, there's more to it, but this is a really good way of doing this. Okay? And then this, when I'm done, I could run the postcode, make sure I pick the Haas. Again, I'll explain all of this next time. So I'm going to use my Haas machine with an A-axis. This one. Run post. Yeah. Sure, replace it. Yeah. Now this is what the machine will read. In fact, all the 3D printers and the laser and the Haas all read the same G code. G or M8 means the same thing for everything. G1 means the same thing. G0, which we will learn later. And these are all just coordinates. Okay. So this we would save this on a thumb drive, throw it on the CNC, it would actually, as long as we set everything up the way we were supposed to set it up, at the end we would have this part.
Is
Now,
it what you with that?
all right, thanks for watching. If you guys have any questions, let me know. But again, remember, the only thing you're supposed to turn in today is this, a screenshot of this. I don't care about anything else.
On your TV.